Okay, this is the graph of tangent. Tangent's going to be a little different than sine and cosine. We're going to still split everything into 4 equal parts, but we're going to start by doing pi over 2, and then we will go back a negative pi over 2. And so I think, where does that come from? Well, the period of tangent is pi. So you're always going to start with half of the period here, because you're going to put half of the period on the positive and then half of the period on the negative. And we'll split that into 4 equal parts, so 0's right there at the origin. And then half of pi over 2 is pi over 4. Whoops, it's not supposed to be negative. And then over here, this would be negative pi over 4. Okay, so those are our tick marks we're going to use. The amplitude of tangent is none, because tangent, you will see, does not have a max or minimum. Let's get some of the points for these. Let's just do these 5 points. So tangent of 0 from your unit circle would be 0. Tangent of pi over 4 and negative pi over 4, if you looked at your unit circle, you'd have square root of 2 over 2 divided by square root of 2 over 2, or the x and y have the same values, so the tangent of pi over 4 is just 1, and then negative 1. And then tangent of pi over 2 is where sine is 1 and cosine is 0, so that's where we have this undefined value. And we show undefined values with a vertical asymptote. And this is one period of the tangent curve. So it comes down, it gets really close to this asymptote, and then comes through like this. So it really, let's see if I can draw that maybe a little better. Maybe the best way to start would be start at the origin, because it's kind of like a parabola going down, and then kind of this parabola-shaped curve going up this way. So it changes concavity at the origin. Okay, so that's one period of the tangent graph. That's all we're going to graph, but this would go on forever. So if I continued on, the graph would look like this, and it would just repeat this cycle over and over again. Okay, so that's tangent. Now let's take a look at cotangent. So cotangent will have a lot of the same properties as tangent. The period is going to be pi, and the amplitude is none, because there will be no max or minimum. For cotangent, I would recommend you just memorize the graph, same thing with tangent, but also that you can think about the reciprocal. So we went through the origin for tangent. Well, if I take the reciprocal of 0, I get undefined. So cotangent's going to have an asymptote at the origin. And we're actually going to start there with cotangent. So let's go out our 4 tick marks and say, here's pi. So we're going to go from 0 to pi for a full period. And that's another asymptote, or cotangent of pi is undefined. And then if you think about the asymptote of tangent, which is at pi over 2, if I take the reciprocal of undefined, I get 0. And so cotangent goes through pi over 2, 0. Or you can think of the unit circle there also. And then we also have this common point of pi over 4. Well, tangent was 1. If I take the reciprocal of 1, I still get 1. We didn't find this point with tangent, so we'll go with the pattern. We could use our unit circle to find that the cotangent of 3 pi over 4 is negative 1. So here are some differences between tangent and cotangent. Where the asymptotes are, they're just kind of shifted over, and then also the direction of the curve. So tangent, as you go from left to right, is increasing in between the asymptotes. Cotangent will be decreasing between the asymptotes. So it'll look something like this. And then if we were to, we can draw another period this way. We won't label it. We'll just sketch it in. It would just repeat. And so always label your x-axis. It's bad practice not to, but we'll just label one period in this case. And negative 1 and 1, I forgot to put those on there. The other thing we'll mention is domain and range. Domain's a little tricky, and we'll have to talk about domain of tangent too. So for domain of cotangent, we're always going to start with the first asymptote. So we'll say this is our pattern, first asymptote. And then we're going to do plus the period times n. So we'll say p times n. That'll be our formula to find the domain of any of these, because that's just a way to list the asymptotes. So x can't be 0. We won't write 0. And then, in this case, plus pi n. So where n is any integer, and you don't have to write that out, you can just leave this as the domain. So it's saying, what that's saying is everything's allowed for x except for intervals of pi. So if I plug in 0, I get 0. If I plug in 1, I land on pi. 2, I land on 2 pi. 3, I land on 3 pi. So that will list all of the asymptotes. That's a little tricky. The range is all real numbers, which is not as tricky. Range, remember, is bottom to top. The lowest value is negative infinity. These will go down forever, and then they will go up forever as well. Real quick, let's look at domain and range for tangent. We'll do this way. We'll say tangent, and then domain. So domain will follow the same pattern. We'll say x can't be, got my bar, x such that x cannot be pi over 2. That's the first asymptote for tangent, and then plus pi n. Oops, pi times n, not pi divided by n. And so this is a way to list every single asymptote for tangent. And the range for tangent is all real numbers. So look for patterns. The first thing you should do is just draw these graphs like 3 or 4 times each. And just the same, go tangent, cotangent, tangent, cotangent, to try to get these parent functions memorized. And then when you're done with that, then you'll be ready to transform them.